We're seeing some great presentations. Let's welcome our next top young scientist for 2016. So our next young scientist is Meghna Behari from Sewickley, Pennsylvania. Let's give her a warm welcome. How are you, dear?
Hi, I'm great. How are you?
Good, good. We're fellow Steelers fans. I say that every year. We always have a Steelers fan as a finalist. It's a thing. All right, I'm going to give you that clicker. Good luck. Have fun.
Okay, thank you. Globally, the lack of clean drinking water poses a significant problem, particularly in developing countries. Now, one way we can begin to solve this problem is to make sure that we are analyzing the quality of our water frequently. However, our current water quality testing methods are inconvenient, inefficient, and sometimes unsafe. They include physically taxing handheld meters, extremely expensive data logging machines, and the time-consuming process of traveling to waterways, collecting samples, and bringing it back to a lab. 2 years ago, I worked with a water quality inspector who had to use that time-consuming process. And working with him, I knew there had to be a better way for scientists to conduct their research. That is why I created Aquabot, and my hypothesis for Aquabot is that it will be a convenient, efficient, and inexpensive alternative to current water quality testing methods. Aquabot's initial design was back-heavy, slow, and it was not waterproof. So over the summer, I have been working on the design, and I've added several new components, and this is Aquabot 2.0. Aquabot 2.0 has 5 new sensor capabilities. It is able to test time and date of where you collected your data. It has a strong motor system to withstand field conditions, and it is wireless through Bluetooth and remote control. So the outer components of Aquabot include the upper module, the lower module, the flotation devices, and I used 3M's heavy-duty fasteners and contact adhesive to secure the outer components. The upper module contains the GPS module, the battery packs, the LED system and Bluetooth module, and the sensor chip that contains the program for the sensor. I used 3M's heavy-duty mounting tape to secure all the components in the upper module. So Aquabot has 2 interfaces, and the reason I created 2 interfaces is to apply to a variety of users. So the LED interface, which is the simpler of the 2, blinks a light associating with the quality of water, and this is based off of EPA's guidelines for fresh surface water. The serial monitor interface gives you the exact value of the unit that you were testing for on a computer screen. So all the sensors function through a C++ paced Arduino program that I wrote, and it converts voltage to the respective unit you are testing for through a formula. And currently, Aquabot can test for pH, oxidation reduction potential, conductivity, total dissolved solids, salinity, and gravity. And I tested the accuracy of both the GPS and the sensor to make sure that scientists are getting accurate data. So to test the GPS, I visited 5 locations and compared Aquabot's GPS with Google Maps' GPS. And 100% of the time, Aquabot's GPS gave accurate coordinates to the 10,000th degree. To test the sensor, I used a predetermined conductive solution, and I tested at what value the sensor equilibrated at. And on average, Aquabot's sensor equilibrated approximately 1,000 microsiemens below the manufacturer's specification. So Aquabot's lower module contains the motor system, and the motor system is a key component of Aquabot, as this is what it allows it to run in the water. So it is comprised of 2 9-volt motors that connect to a remote control chip. And the remote control chip communicates with the remote, which is what it allows it to run wirelessly. The propellers, which is what moves the actual bot, I 3D printed and customized, and I 3D printed them using PLA plastic, which is a biodegradable and heavy-duty plastic. And I tested the speed of Aquabot's motor system to determine whether it would be able to run in field conditions. So on average, it went about 0.2 meters per second in a low current environment. In addition, I tested the range of both the remote control and the Bluetooth to test whether it would go into inaccessible parts of waterways. So the ranges lined up pretty evenly. The remote control is out of range beyond 35 feet, and the Bluetooth is out of range beyond 40 feet. So here is a video of Aquabot running in a field setting with pH values being sent back to a computer. For the purposes of this video, I tethered it, so that is the black line that you were seeing. So overall, Aquabot is a versatile aquatic tool that can be used for water quality testing. I would like to thank 3M and Discovery Education for this opportunity, as well as my mentor, Dr. Kathleen Schaefer, and everyone else who supported me in this process. Thank you.
Thank you for that presentation. I would like to buy some of these for the schools I work with, so this looks great. Could you comment on, did you do any testing about how long the battery would last with a system like this?
Sure. So there are two components that require batteries. First, the upper module and the lower module. So the upper module, which is how the sensor functions in the LED system, that is a normal battery life, a few weeks. And you can switch it out every few weeks. For the lower module, which is where the motor system is contained, since it uses a lot of power to run, since it's comprised of two 9-volt motors, it runs out of battery fairly quickly. So I would recommend changing the battery after every use. And that's something I would like to improve in the future, is potentially add a solar panel device so that I'm not using so many batteries and it's more environmentally friendly.
You really just answered my next question. My question was, what are your next steps? Have you thought about that? And obviously you have.
Sure. So at the beginning of my presentation, I mentioned that I want this to be used in developing countries. And one aspect that I have to improve in order for that to be implemented is to make the materials that I make Aquabot out of more globally accessible. So 3D printers and advanced technology is not accessible in developing countries. So in the future, I want to make Aquabot with more accessible resources so that it can be manufactured and used in developing countries.
When it comes to Aquabot, say 5.0, have you considered anything like automation or kind of deploying these in a more permanent basis?
Sure. So in future models of Aquabot, I definitely want to make it so that it can test in all sorts of environments. So currently it can only test in freshwater environments, but in the future there will be a need to test in saltwater environments such as oceans and seas. So in order to do that, I would have to improve on both the motor system and the sensor capabilities. And in addition, like I mentioned, I want to make it out of materials that are more accessible and are also cost effective.
I liked your presentation a lot. So as
Thank
far
you.
as developing country applications go, would you just use it for monitoring water quality? What do you think the applications are there?
Sure. So Aquabot, how it can be used in developing countries is a lot of times people in developing countries don't know whether their water is able to be drinking or if it's potable. So the application for Aquabot is that people who are testing their drinking water sources will be able to see if it's healthy and fresh for them to consume. I've already started to work towards using it in developing countries. For example, the LED interface doesn't require a computer to get data. You can just see what color the light is blinking in order to test whether your water is able to be drinking.
Thanks for a really nice presentation and a great innovation. You did highlight, again, the need for inexpensive, convenient, and efficient solutions in this area. Maybe you could estimate what you think the cost of this would be once it actually enters into the marketplace.
Sure. So currently, what it cost me to build this prototype is, depending on the sensor, it cost me about $200 to $400. Now, current solutions are either thousands of dollars but aren't applicable in home situations, or they're about $60 to $100 but they're not applicable in field situations. So this is a device that can be applied in all environments, and the price range is between those two water quality testing solutions. However, once I start manufacturing it, mass manufacturing it, the price will go down.
There are several probes that already exist that test water quality and send the results via Bluetooth to a smartphone or a tablet. How does your device differ from those?
So one issue with that is you can't access inaccessible parts of waterways. So 2 years ago when I went water quality testing in my local waterways, there was a lot of parts of waterways that I wasn't able to access that were extremely contaminated. So one unique feature about Aquabot is that it is able to travel to middle of waterways and go against the current, and it can collect data from inaccessible parts by humans.
Thank you, Meghna. I appreciate it. I have no questions.
I've got one. I really enjoyed your presentation.
Thank
Could you
you.
tell us how your device measures total dissolved solids?
Sure. So like the sensors, what it does is it converts voltage to the unit through a formula. So thank you.
You did really good. How you
Thank you.
feeling?
Thank you. Good, good. A lot
All
better
right.
than I was before.
Excellent.
Thank you.
All right. So while we get set up for our next young scientist to present, I'd like to call our head judge up. So Dr. Moss, could we have you come up here for a minute? Take you to the microphone here. How are you doing?
I'm good. How about you?
Good, good. For those of you that are watching, well, those of you in the room, I know many of you know Dr. Moss. We call her affectionately the STEM boss, right? So you've been part of this challenge for many years.
Yes.
What do you think in terms of the skills that the students acquire going through this process? Like, how does that translate to their future professional lives?
What these students are doing right now is going to get them a job in the future. And I know many of the 3M personnel right now would hire them. And we're talking to them. And any company would be lucky to hire students with the skills that our finalists are showing, because that they've been definitely showing that they can communicate, they can collaborate, they're critical thinkers, and they're creative. And those are the skills that all of our students need as they move forward into the 21st century.
One of the things I think that, because we see the finalists and you see Hannah, and it's like, it's incredible. And I know there might be some students and teachers like, well, how do I even get started? Like, I don't know that, like, it's just so amazing. It's like, man, I wonder if that's something I could do. Like, any advice to how folks just get
Yes,
started?
I would say to all of the students and teachers out there that every student can do this. And all they really have to do is think about their ideas. Every kid I know has an idea for an invention to make the world a better place. So as students and parents and adults, just help them figure out how to frame that idea and move forward. And these students that are here have grown so much through this process. The same thing will happen to you if you enter this competition.
What is your favorite part of spending the last couple days with the students?
I look forward to this time so much because it gives me such hope for the future. All of these kids are not only brilliant and wonderful kids and fun, they want to make the world a better place and help other people, and that really gives us hope.
Excellent. Well, thank you so much, and I'll let you get back to your head judging duties.